Hi guys, welcome once again to this interesting series which is on machine learning fundamentals. We were on episode 6, in fact 6B, where we had seen some of the examples of implementation of unsupervised learning, and we had taken K-means and PCA, both the examples practically, and deployed them in Python, and we had in fact then analyzed the results. We'll be continuing for episode 7. We'll be having some more examples. One, in fact, one significant example, which is taking both K-means and PCA, and a realistic problem which will be discussed in fact in this, and then it's a scenario which is there, and then it is having a data. We'll be using this time around, instead of having a direct data inside the program, we'll be using a CSV, and that CSV file will be calling in the Python program, and on which we'll be first of all applying applying one mechanism and then other, and then after that we'll be generating the output. This is a little lengthy program, so I might have to copy in between some of the sections. I have in fact divided into multiple 6 to 7 separate sections, and each section I'll be providing you detailed explanation that what it is doing. Most of those things, for example, the skeleton and other things you are quite aware about, that we had discussed in our episode 6 itself, as far as unsupervised learning is concerned. As for the basics are concerned, basics of K-means, how we are applying this particular algorithm, and what kind of code is there, that you are already aware about. But wherever it is required to provide some further explanation, I'll be doing that. So let us move forward, and first of all, let me just put it on display. We are having this initial definition of this is unsupervised learning. We had taken it in the previous episode. There is a problem, actually one problem, which is explained with a scenario, so you can just see that uh, it is this problem is related to network session behavior for clustering for cybersecurity. So the scenario goes like this: a company has exported a CSV file. So a company has exported, they have given, or they have created a CSV file, and they have given that, which is providing in fact session statistics. So this statistics is related to its monitoring system. It has been generated from its monitoring system. So for each session, it has recorded features. So it is having recorded features. And what are those features? Those features are, for example, session duration, bytes that have been sent, bytes that have been received, number of failed login attempts that have been done by the users. So users have tried to log in. How many out of those login attempts were failed? Those attempts also, it will be providing a log of those. Number of ports that have been accessed. So which ports have been accessed, the details about that, and then requests per minute. This is a kind of information which we are having. Now, if you see the nature of this particular data, where we are getting these features, you will see all of these features are numeric ones. So what the company intends to get, what they want actually is, they want actually uh, they do not know in advance which sessions belong to, for example, regular employees who are browsing heavy, browsing heavy file transfer, for example. Activity is suspicious, that means some activity which is suspicious activity. Scanning behavior, some users who are trying to scan the network or scan the digital assets. So such kind of behavior, company is not aware about that. So if you see this problem, this is not having any labeled feature, labeled data present. So the problem is, we can just we can automatically discover hidden patterns and groups similar network sessions without any labels. This is a very strong problem which can be related to unsupervised learning, and there is no target column. The goal is to discover the structure. So what we'll be doing in this is, we'll be first of all putting the PCA. PCA will help us to reduce the feature dimension for battle visualization. So that is number one. And then KMeans will be helping us to group similar sessions. So this is what is intended for this particular example. And in fact, this is in fact the code which is there, and it is importing. So this is on let us, instead of doing it on a PPT, let me just go directly to our VS Code, and let me create a new file out here. So this is a new file. I'm creating a new file, Python file. So this is my new file. Let me save this as I can save it as there are other programs as well for the previous episodes that we have done. So this will be in fact unsupervised, and this is in fact unsupervised. In this one we are having unsupervised main program or combined program. We can just say unsupervised combined. So let us just give this .py, and I have saved it, and now I will be just going through this, and we will just see that what we have to do. So I think I might have to, because this program is not very small, so I might have to just capture the each one of these one by one, and then paste them there. So let me just first of all put this code, and you'll just see. In this one we are not doing anything. This is the same thing which as far as the skeleton is concerned, the same skeleton. We are importing different libraries which we are going to utilize here in this particular program. We are importing from import pandas as PD, matplotlib, and then we are having standard scalar, and then definitely PCA and KMeans we are importing. So I am doing nothing new here. This is the same code which we have used for other examples as well. So there's nothing new. What is in step one now? So this is the basic thing which is there, and then step one, what we are doing is, you'll just see, I will take step one. So what we are doing in step one is, in step one, I will be pasting the code now here, because it will be taking me otherwise a lot of time to write down. So I'm having already a file prepared for this program. So from there, it's a text file. From here I'm just taking it and copying it onto this editor. So now what we are doing is, it is load data set from CSV. So this is something which we haven't done previously. So here you need to just keep your concentration here, that how this is done. We used to do same df is equal to some initialization of the data which we were giving in the program itself. So I can just give examples here. So if you just see, we are saying, for example, x is equal to np.array, then we are providing the data here itself. Or for example, product names I have provided here itself. So this is a previous program. Or in the similar manner, we are providing data here as well. So, but in this particular program, we are doing it other way around. Other way around means we can just have, this is how actually, the data is taken. It will be either taking a data from a CSV file, which has been there, because it will be having maybe very huge number of records in a real, when you are implementing a real, on a real scenario, when you are implementing a machine learning algorithm. Or it can be something which is dynamically capturing from some input device, and from there, it is bringing it to the program. So that is a real scenario which can that can happen. But most of the times it will be through a CSV file. So that is how we are doing it. We are saying df is equal to pd.read underscore CSV. So what this will do is, it will read this CSV file. Either you have to provide a full path here at this point. Full path means it might be at C colon, then it will be, for example, C colon, and then you will be having the unsupervised learning one folder. Inside that folder you will be having one file called as network underscore sessions.csv. That can be a situation, or any location for that matter. If it is at any location, any other location other than the one which I will specify to you, if it is at any other location, you have to put that path here completely. So it might be C colon, D colon, E colon, whatever is there, and then whichever folder you have to give a complete path, to that particular file. In this case, where I have put this network underscore sessions.csv is the same folder where this program is stored. So you can just see this as well. So I will again say save as. If you see, I don't think it will be showing this. Okay, if I say all files, it might be giving me. Is there any option of that? Okay. If I'm saying all files here, so it will be giving me an option of okay, CSV. Is there any option of okay, that will not be there. But all files, yeah, all files option is here. So if you see all files, there is network underscore sessions.csv here. Now I don't need to do anything, just for the sake of understanding, I had put it there. So print original data set. So we are printing this original data set here. So print df. So I'm printing the df, so it should be printing it. And then we are saying print again dataset shape, df.shape. So we are printing it, and then we are giving the shape of the dataset, how it is in the current context, what it is currently, where it is currently. Then we'll be going to the next step. This is something which is which was new. That means we had not done it previously, because we were giving data directly as an input in the program itself. This is for the first time we have shown that we are capturing it from the file, a CSV file. So that is done now, and then we'll be going to step 2, which is it will be selecting one, in fact, only numerical features. So that is there. So where we can just do this? Let me just edit it and paste, and you'll just see select only numerical features. So with this x is equal to df, we are taking, if you just see, there might be multiple values are there. In fact, one column we are leaving, which is not in fact relevant to us at this point in time. I actually forgot to show you the maybe this file, so that will be very it will be very beneficial to see. First of all, if you can just have a look on this network underscore sessions, it will be very beneficial. And second thing is, you can just see this file. It's having session ID, it's having duration, and by exactly the same columns. Just the session ID which is there, it is not numeric. So this particular field we don't require at this point in time. Later on, it might be required. We might require it for some other purpose, but this time around we'll not. So we'll be just excluding that session ID, and other things which are there, other features which are there, those will be taking. So we are taking those features from here. If you just see duration, underscores, and bytes sent, bytes received, failed at login attempts, ports accessed, and then requests per minute. All of these are taken, and then print selected feature. So it will be printing this, print x. Now it will be printing the value of x again for the second time. The original data was that, we are excluding one and printing it again, and then it will be printing the that value, the data which is there. So moving forward, this is very simple. Moving forward to step 3, which is in fact we are standardize the data. So we are trying to standardize the data. So this is step 3, sorry. So step 3 is this, standardize the data. So what is that? Let me just paste this. So we are trying to standardize the data. Scalar is equal to standard scalar. Okay, that you have done in the previous programs as well, 2 programs. X underscore scaled is equal to scalar.fit. So now we are applying it. Fit underscore transform, and then print standardized data, print x underscore scaled. So now we are having a standardized scalar which we have applied to previous 2 programs. On this one, unsupervised 3, and which is named as unsupervised 3. So this one as well we have applied the same thing, and this program as well previously we had applied the same thing. So this is something which is already known. And then the 4th step which is there now we'll be applying PCA to this. We have applied PCA earlier as well, but we'll see how this PCA is applied here. So let us just edit and paste it, and you will see this PCA is applied here. So let me just clear this one as well, and I will just modify it a little bit to get it down, a little bit down. So yeah, a little bit down. Okay, later on when I'll be putting the results. So this is PCA. We are applying it the same x underscore PCA is equal to PCA dot fit and underscore transform. We are applying PCA on the data. So first thing we have applied the we are applying the PCA now. Standardized data scalar, we have used that to display the data in the standard form, and then we are applying the PCA now. So it should be with this particular algorithm we should be getting lesser components now. So how many components we are reducing it to? So we are saying data after PCA 2 components, so it is reduced to 2 components now. So print x underscore PCA original shape dot x dot shape, and then print reduced shape after PCA x underscore PCA dot shape, and explained variance ratio. So PCA dot explain. This is something which we have done in the previous program as well, in the same manner as we are doing in this one. And if you just see this components, how many components that can be controlled from here. So this is PCA is equal to PCA, and then n underscore components is equivalent to 2. So this is here, and it will be reduced to 2 components, and now we'll be having in fact one more part of this, which will be the fifth step. This will be fifth, and then it is having sixth, seventh, eighth. In fact, is not important because that will be for the figures if we want to generate those. So fifth is applying K-means. This is a little bigger program, as I was mentioning, because it is having application of both PCA and then the K-means. Now we got reduced features. Now we need the categorization. So that categorization, how we will be doing, we'll apply the K-means clustering. So K-means is equal to K-means and clusters equal to 3. So we are putting it 3 categories. Random state is equal to 42, so that we are getting a constant output, and n underscore init will be 10. That means algorithm will be checking it 10 times to match the best one. And then clusters equal to K-means dot fit. This is what we are applying it, applying the K-means, and then we are saying cluster labels print clusters. So we are printing here the clusters on which this has been applied. So it should be giving us the categories which are there, separate categories. So going back and going to the sixth step, which is the add cluster labels to original data. So now it is adding the cluster labels to the data. So we'll paste it there. I'm adding these cluster labels. This is what df cluster is equal to clusters print data set with cluster labels. So now it will be having data set we'll be having with clusters. That means different categories that have been created by K-means. So it is that we have given 3. So 3 categories. So it will be having labels with that. So we can just see the data in that manner. So that is step 6, and now 7 is print sessions in each cluster. So now the printing of this will happen. This is the one which in which printing will happen. So we'll be putting it here, go up even, and then say edit and paste it. You'll just see that now we are printing the session in each cluster. So for cluster underscore ID in sorted df cluster, so it is a sorted one. It will be doing sorting in clusters, and then dot unique. Out of that unique, printf session in cluster ID, and then print df cluster equal to cluster underscore ID session ID cluster. So this is actually the printing which will be happening. It will be much more clear when the output generates from for this. This is just for the printing purpose. We have applied K-means already. Now this is just for the printing purpose that we will be printing this cluster here. And then after that we are having now 8th one, which is 8th part of it, which is not mandatory, but this is just a plot show which you have not done for the first time. This is multiple times we had been doing this, which just gives us a kind of visualization, better visualization. So this is the code for that. So this is, plot PCA reduce data with clusters. So this will be plotting with the, lesser clusters. That means, sorry, three categories. And in fact, it will be giving us a graph for that, and you will be able to see that. So these are the characteristics of the graph, which are principal component 1 and 2 will be from x-axis and y-axis, and it will print grid and rest of the things which are there, for which you have already, I believe, done. So this is a full program which will first of all reduce. It will be giving us first the standardized data, uh, the original data, the standardized data, and then it will be applying the first thing, that is PCA. That PC, after applying PCA, we have seen that, application of PCA previously as well. First it will apply PCA so that the feature set is reduced. So as the feature set is reduced, then after that it will be printing it, and then again it will be applying the K-means. K-means will be categorizing this, and we have given that it should be two categories. Clusters also in PCA, we have said that there should be two clusters. There are multiple features. In fact, it will be reducing them to two principal components. So that principal component analysis, it will be reducing to two principal components, principal component 1 and principal component 2. For example, those can be any two features that are given there. Out of the features which we have already mentioned, there are duration, bytes received, bytes sent, failed logins, ports accessed, and requests per minute. So all of these, out of them, it will be prominent uh, you know features. It will be reducing it to that. So this is what will be happening, and then after that it will be the K-means, which will be in fact giving a categorization, putting it in different categories, so that we'll be getting one labeled output from there. So let us just save this and run this program. We'll see if there are any errors in this. Okay, so the output is generated. In fact, with the plot as well, you can just see we're exactly having the same thing as a file. So first of all, we have said that original data set, you print it. So that's what we are giving that code. So if you can just see this, x is equal to this one. First of all, we printed the df. It is with session ID. So next we are printing without that. When we have applied this x is equal to df and we have reduced that, you will see that ID is not there. So it is starting from duration underscore seconds, then bytes sent, bytes received. So these are the columns which are there, and then this particular thing is done. So we are printing the selected features, and this code is executed now. So you can just see this. Now we are having the scalar, and then we are printing it with scale. So this is actually the standardized data. You should be knowing the a standardized data formula as well. That is quite simple. And then how PCA actually is working on that. For that you should be knowing the mean and the standard deviation. There is a simple formula which you can just see as well. That is, it is not being done by you. It is being calculated by the program itself, by the algorithm itself. So this is a standardized data, and after PCA, we are having these 1, 2, 3, 4, 5, and 6. We're having 6 features. It has been reduced to 2, as we have mentioned 2. So that is here. Now, if you just see this particular thing, data, PCA and components. So we have standardized data. It is printing. So that printing happens here. It is printing x, x underscore scaled, and then PCA, which is here, and we are applying this PCA with this code, and then printing the PCA that is here. So this printing of PCA happens here. That means we have now achieved those 2 components which we have mentioned. Then it is saying original shape was 15:6. So 15 records were total, but there were 6, you can say columns or features. Now it has been reduced to 15 into 2. That means 15 records will be same, but there will be 2 columns or 2 features only. Okay, and then explained variance ratio. So the first one, the first column which is there, it is having 63% of information which it has taken. and the second column is having 36. So 63 and 36 is 99%, if I'm not mistaken. 60 and 30 is 90, and then 6 plus 3 is 9. It is 99 point some percent, which is, that means with these two features itself we are getting 99% of the 99.6% of the information, or 99.9% of the information, which is almost all the information which is there. So that is what we are getting with this one. And then cluster labels. So now we are having, these are the labels, cluster labels we are putting, and data set with cluster labels are here. So these are the cluster labels which are there. Okay, this is the data set with cluster labels. And then we are having sessions in cluster 0. So these are the sessions. Now it will be dividing, K-means will be dividing it into 3 categories. So these sessions are falling into category cluster 0, then cluster 1 and cluster 2. So there are 3 separate categories in which this data is falling. We had told you to give 3 categories. And for this one, what we are doing with this code, which is here it is just, K-means is applied, and then it is printing the cluster, and it is printing this cluster with the cluster ID, each of them in separate, for separate IDs it is putting 3 clusters, because 3 clusters are generated. So with this cluster ID it will be printing them all with this for loop, and it will be running for 3 times. So those outputs are here 0, 1 and 2. So after this particular thing is finished, this is the end of this, and then after that we are having the plotting of a graph, which I shall be showing you. This is the plotting of the graph, which has happened along with this program itself. So this plotting has happened. You can just see we are having 3 groups created. This is S, these are, this is one with the green, one with yellow, so one with the brown color. So these 3 separate categories have been created. This is principal component 1, which is playing a role, and principal component 2. Principal component 1 is having 63% of the significance, and principal component 2 is having 36%. So with these two, 99.6 or 99.9% of the total information we are able to grasp. Rather than taking all the data, we are reducing it to this one. And then these are, these have been categorized by K-means into 3 separate groups. Now the company knows that these are because the company which has given this data, we can just put their, if we put the scenario back, first of all, let me just put the scenario back for a moment. So if we are putting the scenario back and see that, what happens there, if you just see the scenario, it is saying that problem is, can we automatically discover hidden patterns and group similar network sessions? That is what exactly we have done. So we are discovering hidden patterns. It is there is no label in the data, but with unsupervised learning, it is just putting those similar things together with K-means. First of all, reducing the feature set from 6 to 2, and in fact, K-means helps group similar sessions. So it is then showing those sessions which are having similar characteristics, they are grouped together. Now one thing is very important here, that the data on which we have tested it is having few values, that is 15 values. In a real scenario, these might be 15 million or 1.5 million, for example, records. So on those it will be doing categorization. There might be 3 categories, there might be a few more categories, it might be 5 categories. But with that, when we are giving this back to the company, they will be able to understand what are the different categories. And this can go as an input as well to identify, in fact, the risky behavior which is there. When we are analyzing and monitoring a network, it's a very, very beneficial implementation for cybersecurity. When we'll be monitoring the network traffic, this categorization will happen. With this categorization, what we'll be able to do is we'll be able to put them in different categories, and wherever we see a behavior of a particular session which is falling in that risky category, we can stop that. So this is going to play a huge significant role and this is something, in unsupervised learning, this fits the unsupervised learning. And I think, with this one you would have got a clearer understanding of how this K-means, PCA and K-means, principal component analysis, and K-means can be deployed in a single program, which I was mentioning in the previous episode. I was mentioning that this will be, in fact, these will be useful, beneficial when we are putting them together. So in this program we have shown that how these can be together, these how we can utilize these two together, and then solve a significant problem, which is in fact in this case a cybersecurity problem, where we can identify those sessions and put them in different labels and categorize them in. There can be 3 categories, there can be 5 categories depending upon our requirement, but this particular program was showing 3 categories. And that's it on this particular video, which is for the episode 6. It was taking a comprehensive example using Python for unsupervised learning, which was putting both K-means and PCA, using K-means and PCA in a single program, so that we can first of all reduce the number of features with PCA, and then do the categorization into 3 different groups or categories with K-means. That's what we have achieved for a very realistic problem, and it can be beneficial for that. I hope this would have been very helpful for those, especially intended audience is those who want to learn fundamentals of machine learning, and these examples will be very beneficial for them to understand this. We'll be coming up with next with the reinforcement learning, maybe a deeper understanding first of all of reinforcement learning and where that can be applied, and then the practical implementation of reinforcement learning with different examples, basic examples, and then little advanced examples as well. And by the end of this series, which in fact it is machine learning fundamentals, these 3 types will be taking and deep diving into supervised, unsupervised, and reinforcement. At the end of it, there will be complex programs which will be implemented for all 3 different types of machine learning. So keep in fact watching this particular channel. Provide us your valuable feedback, if that will be very beneficial to us. In case it can be critical, there's no problem in that. So be very critical, provide us a realistic feedback, how much beneficial the series is proving for you, for those of you who are just new to machine learning. So it is intended for those. And in case you find it beneficial, please subscribe to the channel and watch it more and more. Thank you so much once again for connecting. See you.